Good evening, my dear students. In the application of Lagrangian formulation, we are going to discuss about the next classical system is spherical pendulum. So, I want to show lively how can we understand what is the meaning of spherical pendulum, how can it moves. Now, this is a particle. It is moving freely everywhere in space. Now I want to restrict the movement of the particle, then I should connect with a bob. Okay, now the moment of the particle is restricted by the bob. So now this particle is moving with respect to the bob, and also I want to fix the another end of the bob at a point. Now this particle is moving in a circular path. Like this. Okay, now this particle is moving in the same circular path on a spherical shape or on a sphere. Now we can also write the dots like this, and also the bottom of the circle. So now we can imagine this is a spherical shape. Now we put the axis, because the spherical shape is three-dimensional. This is z axis, y, x. So now we can understand easily this particle is moving in a circular path on the sphere. Okay, now this particle moving vertically and horizontally. Therefore, two more coordinates are involved with the moving of the particle is theta and pi. Those are spherical coordinates, already we know. Okay, now this particle make an angle theta with the z axis, and the same particle makes an angle pi with x axis. Now this particle moving along the circular path, it makes a small angle sin theta. Therefore, from the figure we can easily write the velocity of the particle as r theta dot plus r pi dot. Okay, with a small deviation in the horizontal path, that is sin theta. So this is the velocity of the particle moving along a circular path on a sphere. Here we put r. R is the radius of the sphere. Okay. Now we can write the kinetic energy of the particle. Kinetic energy T is equal to half mv square. And also we can put the value in this equation of m r theta dot plus r sin theta pi dot the whole square, and put this square inside the bracket of m r square theta dot square plus r square sin square theta pi dot square. Then take r outside of m r square theta dot square plus sin square theta pi dot square. Actually, I forgot to mention about force. Where is the force acting here? Actually, here force acting vertically, but it is not centralized. And also, we don't bother about the force because already we know that if a system is constrained, there is no applied force. So we no worry about the force. Where is the force and where it is acting. So now only concentrate in the energy equation. Then V is the potential energy, that is equal to m g r cos theta. Now we know that the Lagrangian is L equal to T minus V. Then we can substitute the value of T and V. The T value is of m r square theta dot square plus sin square theta pi dot square, and then minus mg or cos theta. So two more coordinates are involved with the equation of motion of the particle here. One is theta and another one is pi. So we need to write the Lagrangian equation of motion for theta and pi. First we can write the theta. For theta, dou L by dou theta dot, that is equal to, we apply here theta dot only involved with the first term. Another term theta and theta both are cancelled. Then of m r square theta dot square here. Then we can differentiate here. It will get the value of m r square 2 theta dot. 2 cancelled, remaining is m r square theta dot. M r square theta dot. Okay, this is the dou L by dou theta dot. If you cannot understand, I can explain here. Now we put the of m r square inside the bracket term. We get of m r square theta dot square. Of m r square theta dot square. Remaining are cancelled because we are differentiating with respect to theta dot only. Therefore, we can differentiate here of m r square 2 theta dot. 2 cancel, remaining is m r square theta dot. Already we write here. Okay, then dou L by dou theta, that is equal to, again we put the of m r square inside the bracket, of m r square theta dot square plus of m r square sin square theta pi dot square minus mg or cos theta. Now differentiate with respect to theta, this term is cancelled. Okay, then of m r square sin square theta pi dot square. Now we differentiate with respect to theta. Sin square theta, get the value is applying trigonometric formula 2 sin theta cos theta, then of m r square 2 sin theta cos theta pi dot square and minus mg r cos theta. Cos theta is replaced by minus sin theta, and already we get minus and we put here minus into minus plus, then mg r sin theta. Finally we rewrite the equation as 2 to cancel, m r square sin theta cos theta pi dot square plus mg r sin theta. So dou L by dou theta. Similarly, we can differentiate the equation for pi, dou L by dou pi dot. We get a value pi dot square here. We put of mr square here, theta dot square is cancelled and cos theta is also cancelled. Then we have to differentiate only of mr square sin square theta pi dot square only, then of mr square sin square theta 2 pi dot, 2 to cancel, then finally mr square sin square theta pi dot only. And then we have to write dou L by dou pi. Here no pi here in this equation, so all terms are cancelled, therefore dou L by dou pi is 0. Now we can apply the result in the Lagrangian equation. First we put dou L by dou theta dot, that is d by dt, minus dou L by dou theta equal to 0, and similarly d by dt of dou L by dou pi dot minus dou L by dou pi is equal to 0. Now we put the equation for theta, dou L by d of dt m r square theta dot here, and then minus dou L by dou theta m r square sin theta cos theta pi square plus mg r sin theta. Okay, similarly here d by dt of m r square sin square theta pi dot, so remaining is 0, therefore that is equal to 0. Here one correction, we put the minus, when we apply this value here, put minus here also, so here minus mg or sin theta, this is correct. And also we can write the same equation here, differentiating the factor theta dot. Already we discussed, no need to explain again. Therefore mr square theta double dot, to get the second order differentiation, theta double dot minus m r square sin theta cos theta pi square minus mg or sin theta equal to 0. Then here the differentiation factors are involved with only theta and pi spherical coordinates. Therefore we can write this equation as mr square d by dt of sin square theta pi dot equal to 0. So these are the solution for the spherical pendulum in the form of Lagrangian formulation. That's all.